Let's see question number 1.63 of Irodov. The question states the following parameters of the arrangement of figure 1.11 are available. The angle alpha which the inclined plane forms with the horizontal and the coefficient of friction between the body m1 and the inclined plane. The masses of the pulley and the threads as well as the friction the pulley are negligible. Assuming both bodies to be motionless at the initial moment, find the mass ratio m2 by m1 at which the body m2 number 1 starts coming down, b starts going up, and c is at rest. This is the diagram of the problem, and let me draw the forces on the system of m1 plus m2 as a whole without friction first. So its weight is m2g vertically downwards, and on this the component of weight m1g component of weight along inclined plane is m1g sine alpha, and the friction between m1 and the inclined plane, maximum static friction between m1 and m2, or let me just write the friction only. The friction, static friction, is self-adjusting, acts according to the need, and the coefficient of friction is k, and is the m1g cos alpha. So maximum friction would be k m1g cos alpha. So friction between m1 and inclined plane will vary between vary between 0 to upper limit, and the upper limit would be k1 m1g cos alpha, and whatever will be the need, according to that thing it will act. So the first option was we have to find the ratio of the m2 by m1 such that this m2 starts going down, just starts coming down. So it is just start coming down, mean the static friction it's just from rest, it's just starting moving. So static friction is just just reaches its maximum value. So it is going down here, so it is going up here, not going up, just about to go up. So there is going to be a relative motion, just relative motion is eminent relative motion between m1 and the inclined plane, and with respect to inclined plane, m1 is going to move in the in the upward direction. So and it is about to move. So static friction will act at its maximum and opposite to the tendency of the motion. So if we talk about the option A, in option A, static friction will act at all its might, and which is Fs max. Fs max is a k1 m1g cos alpha, and opposite to the tendency of the motion. So that would be here k1 m1g cos alpha. So if we balance all the forces along the incline, I can straighten the whole thing. So this tension will balance these two, and this tension will balance this thing, and adding all, if we look m1 plus m2 as a whole, on this direction m2g, on this direction m1g sine alpha plus k m1g cos alpha, and they will balance each other for this to be at rest at this moment, and it is going in the just about to go up. So the equation will become m2g is equal to m1 sine alpha plus k m1 cos alpha into g, and g will get cancelled, and we can divide this whole equation by m1. So m2 by m1 is equal to sine alpha plus k cos alpha, and that is our answer to part A. Then in part B, m2 just start going up. So if the m2 is just going to go up, so m1 will just go down. So what will happen now? Now the static friction will not act in this direction. Now relative motion is going to take place between inclined plane and m1, and with respect to inclined plane it is going downwards. So static friction will reach to its maximum value and will act in the upward direction, and the same static friction k m1g cos alpha. So in this case, here m2g in m, and here the sum of these two in this direction is m1g sin alpha minus k m1g cos alpha. They are just balancing it, and just a little later it will go like this, because this is going downward and this will go upward. So here now our equation will become m2g is equal to m1 sin alpha minus k m1 cos alpha into g and g get cancelled, divide by m1 both side, so m2g, m2 by m1 is equal to sin alpha minus k cos alpha. And then we have to find the condition, value of m2 by m1 such that the whole system is at rest. For this thing it is going to be just in the downward direction. For this thing it is going in the upward direction. So obviously if m2 by m1 is between these two, then it will rest, otherwise it is moving. But we can check it separately. So suppose there is no friction right now, and we are going to get the value of m2 by m1 when such that this whole system is at rest. m2 is at rest, so whole system is at rest. So we can take two cases. First thing is m2 greater than m1 sin alpha. We can think that there are two masses. On this side there is a mass m2, and on this side there is a mass m1 sin alpha, and they multiplied by g, so the force become m2g and m1g sin alpha. So just leave it like that, and suppose there is no friction, so this will go down if m2 is more than m1 sin alpha. This will go up if m2 is less than m1 sin alpha. So without, suppose there is no friction. Now the role of friction, suppose it has to be at rest, and m2 is more than m1 sin alpha, so this will go down and this will go up. To balance this, we will need, because it is going down, m2 is more than m1 sin alpha, so we will need a static friction here, just the right amount of the static friction to balance the net, to balance all the forces. So in this case, if m2 is greater than m1 sin alpha, so what will happen? This m2g is the sum of m1g sin alpha plus fs. So fs plus m1 sin alpha into g is equal to m2g. So fs is equal to m2 minus m1 sin alpha into g. And we know that fs is this. Fs has a upper limit, and this is the upper limit. So in inequality form I can write fs is less than k1 m1 g cos alpha. So, and this g and g will get cancelled, so we will have m2 less than m1 sin alpha plus k m1 cos alpha. Divide both sides by m1, so we will get m2 by m1 less than equal to sin alpha plus k cos alpha. And similarly, let's test the case that m1 is greater than m2 sin m1 sin alpha is greater than m2. If m1 sin alpha is greater than m2 and without friction, if we think, then this mass will go downward and this will go up. And to keep them static friction should act now in this case in the upward direction, just the right amount, so that the whole system is at rest. So now what will be the equation? The equation will become, here I can write m1 g sin alpha minus fs is equal to m2g, or fs is equal to, or m2g minus okay, we can write that way also, m1g sine alpha minus m2g is fs. That is fine. And then again we can put this value of fs. So writing this value of fs, we'll get m1g sine alpha minus m2g less than equal to k m1g cos alpha. G will get cancelled on both sides, and then divide both sides by m1. So sine alpha minus m2 by m1 is less than equal to k cos alpha. So what will get the value m2 by m1 is less than equal to sine alpha minus k cos alpha. And obviously m2 by m1 will be, this was for the body to be at rest. So overall condition for which the body is rest, combining these two, we can write that if m2 by m1 is greater than, if m2 by m1 is one minute, yeah, that is fine, and here it will go and that will become greater than, because if that will go on that side, so this will become that. So m2 by m1 will be greater than equal to sine alpha minus k cos alpha and less than equal to sine alpha plus k cos alpha. So this is the range in which this m2 by m1 should be for it to be at rest.